Okay, now we proceed to the Poisson distribution. Okay, what is Poisson distribution? Okay, this Poisson distribution represents the number of occurrence of a specified event in a given unit of time or space. Okay, so it can be specified event in a given time or area or volume, week or distance. Okay, this Poisson distribution counting the number of x of times for a particular event occurs during a given any unit of measurement. Okay, in this Poisson distribution, the unit of measurement is very important. So you have to be alert, okay, on the unit of measurement. The notation of the Poisson distributions the mu is equal to the mean or average of event. And the formula of the Poisson distribution in which the mu is the mean or average of an event and the x is the number of success event. Okay, this x you can get from the question. Okay, now we look at the mean, variance and also the standard deviation of the Poisson distribution. Okay, so the mean of the Poisson distribution is equal to the mean. The variance of the Poisson distribution is equal to the mean. And standard deviations of the Poisson distribution is equal to the square root of the mean. Now we look how to get the probability from the Poisson probability table. Okay, let's say, okay, we have the Poisson, the mu of the Poisson, let's say we have 4. Okay, so this is the Poisson distribution with the mean is equal to the 4. Okay, now we want to get the probability when the x is greater or equal to 3. So now, when we have the greater and equal to, that means we can get the answer from the table. Okay, now, this m is equal to the average or mean. So that means it's equal to the mu. Okay, this m is equal to the mu and this r is equal to the x. Okay, so if we see from this question, we have the mu is equal to 4 and we have the x is equal to 3. So now we have 0 0.1, 0 0.2 up to 1, then we have 1.1, 1.2, 1.3 to 2. So the 4.0, the 4 is here and the x is equal to 3 is here. Okay, so we get the answer is equal to 0.7619. So this is how you look the probability from the Poisson probability table. Example 11. Okay, so the Poisson distribution and the formula of the Poisson distributions. in which the mu is the average or the mean of the number of events, and your x is the number of success. And this x, okay, is from the question, what the question asked for. Okay, now we look at the example 11. Okay, we have the number of flaws follows a Poisson distribution with a mean. Okay, so that means we have the mu is equal to 2.3 flaws per millimeter. That means for 1 millimeter. Okay, so for 1 millimeter. This unit of measurement in Poisson distribution is very important. Okay, the question asks you find the probability exactly 2 flaws in 1 millimeter. Okay, that means the question asks you to find exactly 2. Okay, and your mu in 1 millimeter. Then we have the mean of 2.3 flaw per millimeter. That means your mu, the mean or the average is 2.3. So for the question A, when we have the Poisson, mu is 2.3. So the question asks you as exactly 2. So it's equal, okay, we use this formula, okay, E exponent, E negative mu, your mu is 2.3. Then we have mu, your x is 2 over 2 factorial. Then we must solve this and get to 0.2652. Okay, now we go to the question B, 10 flaws in 5 millimeter of wire. Okay, now we have 10 flaws. That means the question asks you to find when the x is equal to 10. Okay, now how about the mean? It is given 2.3 flaws per millimeter. Now you have the 5 millimeter. The question asks 5 millimeters. That means your mu 2.3 must multiply with the 5. Then we get 11.5. So it's equal to 11.5. So that means your new mu is equal to 11.5. Okay, so the question asks when the probability x equal to 10. We have the new mu 11.5. Then we have mu, our x is 10 over 10 factorial. Then to solve we get 11.30. Okay, now we proceed to question number C. At least one flaws. That means the question asks you at least. That means greater or equal to 1. Okay, in 2 millimeters. Okay, the question gave you the mean of 2.3 for 1 millimeter. Now the question asks 2 millimeter. That means you must calculate, you must get your new mean. Okay, so that means for question number C, you have a new mean. As Poisson, your new mean is 4.6. And the question asks you the probability at least 1. That means x greater or equal to 1. That means and your x equal to 1 or x equal to 2 and Okay, so we can get this answer, okay, when x greater or equal to 1 and your Poisson is 4.6 by using zone table. Okay, so this is a Poisson distribution table. So we want to look for probability x greater equal to 1. So we can get the answers from the table. Okay, then it's from the Poisson with the mu 4.6. So 4.6 is here. Okay, your x equal to 1 is here. So you get the answer is equal to 0.9899. Okay, so from the Poisson table, we can say that our probability is equal to 0.9899. Okay, then we can solve also with this method. Okay, x greater equal to 1. That means the number that is excluded from x greater equal to 1 is x equal to 0. That means by using the theory tree from the chapter 1, okay, then we can use and get 1 minus, so when x equal to 0, E, our net mu is 4.6, our x is 0 over 0 factorial. Okay, so we substitute this x equal to 0 in the Poisson formula. Then we get the answer is 0.9899. So we get the same answer. Okay, we proceed to example 13. Okay, the number of incorrectly dialed number mapped per hour, okay, by a new telephone operator has a Poisson distribution. So the question already given is a Poisson distribution. So it is given the probability that she dials all the number correctly is 0.90. That means the probability she dialed all the number correctly is 0.90. So the question asks to find the mean number. Okay, the mean number, that means find the mu of incorrectly dialed number per hour. Okay, so now since this is the Poisson distribution, okay, we must look at the unit of measurement. So it is given per hour. That means your unit is per hour and the question asks per hour. That means your mu is same. Okay, so the question asks you to find the mean and it's given that the probability, the number correctly is 0.90. So find the mean number of incorrectly dialed. That means when we have the number correctly. Okay, so incorrect, that means x equal to 0. Okay, so now your probability when x equal to 0 is equal to 0.9. Okay. So we know that when x equal to 0, the formula of the Poisson distribution is E negative mu. Then you have mu x, our x is equal to 0 over 0 factorial. Then from here we know that probability x equal to 0 is equal to 0.90, and we know that 0 factorial is equal to 1 and mu power of 0 is equal to 1. So it's equal to E negative mu. So when we have the e exponent negative mu, so we must use the ln to eliminate our exponent. So ln exponent, ln e become negative mu, and it's become ln 0.90. Then we can get our mu is equal to negative ln 0.90, in which is equal